This is section 2-4, average velocity and average speed. We're first going to look at average velocity, then we'll look at average speed, and then we're going to study motion graphs and see how to use motion graphs with these two ideas. Let's look at average velocity first. Velocity is a vector. It has both magnitude and direction. The average velocity equation is explains the rate of change of displacement. Now remember, displacement is a vector also, so that's why velocity and displacement go together. So average velocity is the rate of change of displacement, and the equation is this right here. It's displacement divided by time. It's x2 minus x1 all over t2 minus t1. Displacement divided by time. All right, now let's take a look at average speed. Speed is a scalar, so it only has magnitude, and the equation is this. It's total distance all over time, not displacement, but distance all over time. So we're going to go ahead and take a look at motion graphs, and we're going to discuss this in terms of average velocity. So if you look at this graph, pause the video right now, and I want you to answer this question. What is the average velocity of the object moving according to this graph? The green line shows what this object is doing. So pause the video now, please. The object is at rest at -2 meters. This is the answer. So the velocity is 0. It never moves. And you'll notice that the slope is 0. That green line has a slope of 0, so therefore the velocity is 0. If you have a displacement versus time graph, the slope of your motion, the slope of that line, gives you your velocity. It's a very important idea. The slope of a velocity versus the slope of a displacement versus time graph gives you velocity. You'll notice, actually, let me go back to that. You'll notice that the equation displacement over time is like change in y over change of x. All right, so here's a graph, and I want you to decide what motion this graph represents. So pause the video again and write down what you think this graph represents. The answer is that it starts at -5 meters, and it does not move at a constant velocity. Now, how do we know that the motion is not constant? So pause the video and answer that question. We know because the slope of the line changes. Slope represents velocity. This is a curved line, so the slope is always changing. It's a curved line, so the slope is always changing. Therefore, the velocity is always changing. Now, how do we calculate average velocity with a curved line? Remember, we don't want instantaneous velocity, we want average velocity. We just do what the equation says to do. We take the displacement, we start at -4 meters. At that one point, we go up to 2 meters, so there's a displacement of 6 meters. It occurred in a time of 3 seconds because it went from the 1 second point to the 4 second point, so that occurred over a time of 3 seconds, so the average velocity is 2 meters per second. In other words, it's the slope of the red line. Not the slope of the green line, but the slope of the red line. Here's another example to look at. This person drives along the red line here, then walks along the red line. We want to find the average velocity. Well, it's just the slope of the green line from the starting point out to the ending point. Remember, the slope of that position versus time or displacement versus time graph gives you the average velocity. The slope was much higher when they were driving than it was when they were walking. To get the average, you just find that the slope of that green line, and which turns out here to be 16.8 kilometers per hour. So you can pause the video and just double check to make sure you understand that, but that's the situation. Our wrap up is that velocity is a vector, the equation, or speed is a scalar, and we're going to write the equations down here, and you need to know what the equations are. We have them from before here, but velocity is a vector, you need to know the equation. Speed is a scalar, you need to know the equation. And motion graphs help us to analyze the motion of an object. And as you write these equations down, you should in your notebook make a list of equations in the back of that notebook throughout the whole year so you can have them when you're taking tests and studying for the AP exam.